With the Starship, SpaceX is building the biggest and most powerful spacecraft. It will open up new frontiers in space for humankind by helping Musk fulfill his burning desire to put permanent residence on Mars. However, the Starship depends on the Raptor rocket engine that SpaceX is building in-house to lift off and travel through space. In this video, we dive into SpaceX's newly revealed Raptor engine. A spacecraft is not flight-worthy without the rocket engines that will provide the thrust needed to lift off and escape the Earth's gravitational pull. So when SpaceX conceptualized the Starship as a spacecraft that could lift more than 100 tons of payload to low Earth orbit, it knew it needed powerful rocket engines. The Starship's booster was initially purposed to offer 16 million pounds of thrust, but Musk's subsequent comments suggest it could reach 17 million pounds. Whichever the case, the Starship would generate more than double the thrust produced by the most powerful rocket ever to fly, the Saturn V, which flew for the last time in 1973 and generated 7.6 million pounds of thrust. Unlike an aircraft that speeds horizontally before taking off, the Starship, like most other rockets destined for space, takes off vertically, meaning its thrust must be higher than its weight. This immense power is needed for the Starship to play its role of moving lots of cargo around. Its topmost mission is to Mars, which will see it transport tons of cargo between the Earth and the Red Planet. It will also be configured to move people. SpaceX was not in short supply of rocket engines. For example, SpaceX's Falcon Heavy powerhouse uses a collection of Merlin engines made by SpaceX itself. SpaceX made two types of the rocket engine. The sea-level Merlin engine produced 845 kilonewtons of thrust by burning propellant made from RP-1 and liquid oxygen, and is recoverable and reusable. The vacuum variant uses the same fuel but has a significantly larger expansion nozzle to maximize the engine's efficiency when the spacecraft is in the vacuum condition in space. It produces 981 kilonewtons of thrust, and SpaceX claims it has the greatest efficiency ever for an American-made hydrocarbon rocket engine. However, this Merlin engine was not good enough for the Starship, and SpaceX decided to build a whole new rocket engine. It developed and refined the Raptor engine while working on the Starship itself. The Raptor engine began flight testing on the Starship prototype rockets in July 2019. The Raptor engine is plenty powerful and can produce 2 meganewtons of thrust. It stands 3.1 meters high and has a diameter of 1.3 meters. To get the desired result, SpaceX used a combination of innovative design and unusual propellant, which we will get into. SpaceX used what is known as a full-flow stage combustion engine, quite unusual in the rocket industry. In fact, the Raptor is only the third engine in history to use this design, and the first two, the first in the old Soviet Union and the second in the US, never made it past testing. The Merlin uses the open cycle system. What does full-flow stage combustion mean? It means the pump spins a turbine to drive the engine using a pre-burner to initiate the process by injecting a small amount of fuel. In a traditional open-cycle engine, some propellant is spent to begin this process, but with the Raptor, every drop of fuel available is used, making it one of the most efficient rocket engines ever. This makes the Raptor have about 3 times more pressure than the Merlin, despite being similar in size. In actual fact, the Raptor engine is the highest pressure rocket engine ever built. However, there is another major for the better pressure-to-size ratio, which we will see later. Here is how Massachusetts space consultant describes the operation of the Raptor engine. Raptor burns that fuel at a high enough pressure that can then steer the fire from pre-burner back into the combustion chamber and completely burn that fuel with the rest of the propellants. It does this in a very clever way that only the Russians have done previously, by putting all the propellant in the engine through the pre-burners. To contain the high pressure in the rocket engine, SpaceX had to develop a new metal alloy. The fuel is where things incredibly get more interesting. Rocket-grade kerosene is the most common fuel type, but SpaceX switched to methane and oxygen with significant benefits. The most important benefit is that methane has higher performance than other fuels, contributing to the Raptor producing more thrust than the Merlin engine. Methane also costs less, although, in truth, fuel cost is a minor share of the total cost of launching missions. Interestingly, SpaceX aims to make fuel costs a significant part of launch expenses, like the aviation sector, where it accounts for a third of operating costs by bringing down the cost of the rocket itself. This it will achieve partly by making the Raptor engine reusable, which we shall get to in a moment. Using methane as fuel has other benefits. If you can imagine a rocket that has just burnt kerosene fuel to fly, you will notice some deposits inside the engine. This phenomenon is known as coking, and it affects how many times you can reuse the rocket. However, with methane, there is no such deposit. Now, remember the Starship is going to Mars. En route, it will burn the fuel in its tank. Since the Starship is reusable, it has to return to the Earth. But what happens when the Starship needs more fuel to return to the Earth? Apparently, SpaceX considered this before choosing methane as the fuel for the Starship. Mars is thought to contain materials you can make methane from. So, with the right conditions, the Starship's fuel does not have to come from the Earth. This would be a revolution in space travel because it brings up so many possibilities. For instance, think of taking off for a further planet after refueling the Starship on Mars. It is fair to mention that SpaceX's arch-rival Blue Origin is developing its own methane engine called the Blue Engine 4. Back to the economics of the Starship. As stated earlier, reusability is a massive part of SpaceX's plans for its new spacecraft. Musk wants each of the Raptor engines to be capable of flying up to 1,000 times before retiring. The Starship needs enduring rockets because Musk has to move many people to Mars to fulfill his ambitious dreams. This calls for numerous trips, and the best way to reduce the cost is to fly the same Starship multiple times. Musk is not above sometimes exaggerating, so it remains to be seen if a rocket engine could be flown to space 1,000 times. For comparison, the most reflown engines in space belong to the Space Shuttle, and they flew only a few dozen times. Their methane fuel will help with reusability because it is easier to refurbish the engine, unlike when the fuel is kerosene. A stacked Starship needs more than 30 Raptor engines. The upper stage, known as the ship or Starship, takes 6 engines, and they're a mixture of sea level and vacuum variants. The ship needs the vacuum engines to travel through space and the sea level to maneuver for landing. The lower stage, or the Super Heavy, has 29 Raptor engines in the current Booster 4 prototype, all made of the sea level variant. Where does SpaceX make the powerful Raptor engines? It has production facilities in Hawthorne, California, before being transported to its McGregor plant for testing and then to Boca Chica to be fixed on Starship prototypes. However, SpaceX is building a new production plant near the testing site in McGregor. This is where SpaceX will build the next version of its rocket engine, named Raptor 2. It will have a capacity of between 2 and 4 engines per day. Musk says the factory will be the most advanced rocket-making factory in the world. The McGregor site also gets a new test stand for testing the sea-level variant of the Raptor. Speaking of the Raptor 2, SpaceX has started testing this new version. According to Musk, the main difference between the Raptor 2 and its predecessor are much cleaner plumbing, wire harnesses, and a wider combustion chamber throat, which lets the new engines produce more thrust with the same physical dimensions. He also called the Raptor 2 a major improvement in simplification. The test didn't end well because the Raptor engine exploded. However, this is not strange at this stage of development. Let us know what you think of SpaceX's Raptor engines in the comments.